Welcome to solverfy.
This is the answer to Chapter 16, problem number 35 from the Smith Organic Chemistry textbook. And in this problem, we are asked to explain why the cyclopentadienide anion gives only one signal in its carbon-13 NMR spectrum. And so in order to answer this, we're going to draw all the resonance structures for this molecule. And so that is going to look like this. So these electrons can go here. These electrons can go to this carbon. Oof. Sorry, let's try that again. There we go, that's better. And so when we do that, we now have our lone pair situated here with the negative charge. And so from there, the electrons, the lone pair can go there. These electrons can go to this carbon. And so now our double bonds will be here and here, and the lone pair will be here with the negative charge. And so now we can move the electrons like this. And so what you're seeing and what will be really apparent in just one more structure is that really this lone pair could be seated on any of these carbons, and any of these carbons could have the double bonds going on. And so now lone pair and negative charge here. And so lastly, we can move electrons like this. And so now our negative charge is here, our lone pair is here. And so what we've done is drawn a resonance structure for each of these carbons to have the lone pair and the negative charge on them. And so if we go ahead and draw the resonance hybrid here, it's going to look like this. So there's our 5-membered ring, and any of these carbons could have a double bond. Okay, and any of these carbons could have the negative charge, so they're all going to have the delta minus. So they all have a partial double bond and a partial negative charge, and in fact, they're all equivalent. And since they're all equivalent, which these resonance structures and this resonance hybrid make pretty clear, since they're all equivalent, they're all going to give the same signal. And so that's why there's only going to be one carbon NMR signal. Okay, and so that's the answer here. And again, we got there by drawing all the possible resonance structures for this molecule. And when we do that and then draw the resonance hybrid, it becomes pretty clear that all of these carbons are actually equivalent. And so that's why there's only one signal. And that's the answer to Chapter 16, problem number 35.